That's God, right? That's Hawking's mind to God. It really is. This is a conscious computer, okay? At the omega surface in our future. See, there's our Aristotelian final causation backwards through time. And so there's William Blake. And I'll skip all the technical. Okay, this is a picture from MIT. Now this is a picture. Now what this is kind of a. Now this is in Scientific American. It's not astounding science fiction. It's Scientific American. And what this is, it's just a representation of the surface, what's called the event horizon of a black hole. And he's showing it's pixelated. It's sort of like it's like a little computer. It's actually computing. It's an information processing machine. It has what's called entropy and information. And there's a whole theory of this. And this is now mainstream physics. Okay, but this is us. We're looking at a black hole in space, and we're outside the black hole. But it's a computer. And then Stephen Hawking, back in 1973, and a guy named, I think, George Ellis, one of the guys he worked with, they said, well, if the black hole horizon is a computer, then this cosmological horizon, they knew mathematically there was a cosmological horizon even back in, well, they knew it was a mathematical possibility back in 1973. They didn't know about dark energy, so they didn't know our universe actually had such a horizon. But they would say, if in a mathematical universe that was a solution of Einstein's equations, if it had such a horizon, it too would have the same properties, except we're inside the thing. See, this black holes are small, relatively small, and we're outside. It's a collapsed star, say, but the surface of the black hole is a computer. It has what are called holographic properties, but in what's called the de Sitter space-time, we are inside this thing. We're inside the surface and outside the surface, but it's still a computer. It's still a horizon. Now, as it turns out, at that time when Hawking and these guys were writing, they thought there's something in Einstein's theory called the cosmological constant that Einstein had in his original papers in general relativity around 1916. And everybody thought the cosmological constant was zero. See, but what the dark energy is, it's a positive cosmological constant. It's a very small number, but it's a positive cosmological constant. And once you have, and that's from the data, that's from the Type 1a supernova. Okay, so we now know, which we didn't know until 10 years ago, roughly, and we now know that in fact we are inside such a horizon. So instead of just imagine you're inside at the center of this thing, so to speak. Okay, and then it turns out it's a computer, and it turns out, but it's a computer of future. See, it's sending. There was this theory of Wheeler. John Wheeler was a famous professor at Princeton. In fact, Cheryl met Wheeler. He was Richard Feynman, the famous Richard Feynman. He was Feynman's teacher at Princeton, and they were now John Wheeler died just recently in his 90s. He was the inventor of nuclear fission with Niels Bohr. Back in the 30s. So we're talking about these are important men. Okay, and in fact I remember. In any case, so he got the idea in 1940. In 1940, right before World War II was starting, Feynman's a young graduate student with Wheeler, and they're doing these crazy things, and they got the idea that in electrodynamics, that not only do you have influences from past to future, but you have to have what's called the advanced potential from future to past. This advanced teleological. So they first introduced the efficient cause, and it turns out then the war happened, and everybody all went to Los Alamos and made the atomic bomb and all that. And then what happened was after the war, this guy named Fred Hoyle, who was an Englishman, actually I guess he's from Wales, Yorkshire. He's a Yorkshireman, and he was a professor at Cambridge. And in fact, Stephen Hawking has a professorship at Fred Hoyle. But Fred Hoyle used to come down to La Jolla, where I was a graduate student all the time. And so I got to know him a little bit. And so Hoyle took the Wheeler-Feynman idea and developed it even further, and applied it to quantum mechanics and cosmology. So Hoyle set up the basic equations for this kind of cosmological horizon, and that this future horizon would be influencing us from the future, backwards through time. So there's your efficient cause. And not your efficient cause, your final causation. But now it turns out, one of the big mysteries of the world is, why do we get older? It's called the arrow of time, irreversibility, second law of thermodynamics. So the issue is, why do we age? Why do we age? Okay, and this is actually a big problem in physics. That people, in fact, Ludwig Boltzmann, back at the turn of the century, got in such a he committed suicide because he was considered a crackpot by his peers because he was like ahead of them. Okay, he actually committed suicide, I think 1906, and it turns out he was right. He was right. So, but in any case, so there was this arrow of time problem, and in fact, there's a recent book just came out. But well, how are we doing on time?
We have plenty of
Okay. A recent book.
Half an hour.
Oh, okay. A recent book has come out by a guy named Sean Carroll. He's a young, bright young guy. He's a young professor at Caltech. And the title of his book is From Eternity to Here. It's a popular book. It's like a bestseller. Popular book. It's a great title, From Eternity to Here. Yeah, of course, it's a play on From Here to Eternity, right? You know, with the movie From Here to Eternity. But From Eternity to Here. But where is eternity? I mean, we know eternity is not in the past. Goes by, this guy knows, he's a cosmologist, so he knows all this stuff, right? So eternity is not in our past because we know our universe began 13.7 billion years ago. It's pretty, and that's a number that's accurate to about 2%, actually better now, less than 1% error. And that's why it's called precision cosmology. Okay, this is so NASA is paying off because we're getting information like that. So where's eternity? Eternity's in our future. If anything in the future, that needs to be infinite, eternity. It ain't going to be. We know the past is finite. We know we're only 13.7 billion years from the creation of time, as understood in physics. Okay, from the creation of the universe. So he's saying eternity to here. That's sort of saying backwards in time, like final cause, right? Except you read his book, there's nothing in there. It's like God in the New Physics with Davies. He'll probably get $1 million too from the idiots at Templeton Foundation because he's eternity here, like causation. So you can't tell a book by its cover. So the book is a big letdown because you look at the book and it is a good book. He explains the history and all that, and he's a fairly good writer. And he just states the problem. He says, well, I don't have the answer. At the end, you read through 500 pages, no answer there. Okay. All right. Okay. So the point is this, that because this future horizon is like a hologram, like a plate. If you have what a hologram is, you have information on a two-dimensional glass surface. You shine a laser beam through the glass plate, and what do you see? You see a three-dimensional image. Okay? Guess what, folks? You're all hologram images. That's the idea. It's a crazy idea. It's a crazy enough to be true. So the picture that's emerging, and this is very consistent with Teilhard de Chardin's philosophy, that there is this computer. It really is a computer. Actually, it exists even now. Let me get back to that picture. If you look at this, I mean, say we're here in this picture. This is from Tamara Davis's PhD thesis. So we're at this point here. So this is like what's called constant cosmic time. So you see here the mustard color. This is where our future horizon is now, so to speak. There's a cosmic now. You can actually talk about a global cosmic time in these general relativity solutions, cosmological solutions. So we are here, and our future horizon is a sphere over there, but that sphere is not influencing us because the speed of light is finite. So we're actually being influenced from the future. See, this is what's called our future light cone. On this diagram, light rays go at 45 degrees or 135 degrees. That's it's rigged that way. It's just a representation. So what's happening is here. It's at this point, the intersection of what's called our future light cone with our future event horizon. That point, and that's going to be a spherical shell, so to speak, billions of light years away from us. But it's information being radiated backwards through time through the wheel of Feynman effect, this advanced potential effect, that's creating us, so to speak. We are kind of, it's as though we are, it's like those movies, The Matrix and 13th Floor. That's the picture. We are actually being computed we're three-dimensional images. Consciousness, you have to know what is consciousness. That's another. I don't think I could sort of tell you what I think consciousness is from a physics point of view. But it turns out that computer is also a conscious computer. Okay, it's a conscious because of what it has what's called signal non-locality, which is a technical concept in what's called post-quantum theory. It's like just like in Einstein. First in 1905 had special relativity theory, which explained certain things like E equals mc squared, led to nuclear physics, the atomic bomb, and nuclear reactors, all that kind of stuff. Well, then in 1916 he went beyond his special theory. It took him 10 years, and he had because the special theory did not include gravitation. In order to get gravitation, he had to have more general theory. Okay, so things that are impossible in a special theory are possible in a general theory. Hey, wait a minute, where did I hear that before? That's from. That's the New Testament, isn't it? About wine and the new wine and new skins or something like that. That guy. Oh, Jesus Christ!
That guy.
He said things like that. Yeah. So the New Testament, you go beyond. So the New Testament is the Old Testament. Is Einstein's general relativity is the special relativity. You could make that kind of analogy. Well, similar way, physics theories are always limited. In fact, we have what's called Girdles Theorem. There's a book called Girdles Theorem. It's actually a fairly good book. And he wrote another one called The Mind's Eye, Doug Hofstadter. He talks about all this stuff. You can show any finite system of thought that is of sufficient complexity that a man creates. There's always something beyond it. There are true statements you cannot prove within the original system. So you always want to extend your theories. Okay. So just as in quantum theory, certain things are not possible. But quantum theory is a living case of a more general theory. And it turns out, there are a lot of popular books saying that consciousness has something to do with quantum theory. Well, yes, in a way, if you sort of, but technically it really doesn't, because the quantum theory is based on a certain constraint, a certain assumption that precludes consciousness, ordinary consciousness. You can make that argument. And there is something called, there's a technical way of getting beyond that, but there's a certain axiom in quantum theory that does not permit consciousness. Let me put it that way. But you can change that axiom. Just like you went from Euclidean geometry to non-Euclidean geometry. There's the axiom, the fifth postulate of parallels. Well, you can change that a little bit, and you get a theory that will allow consciousness as a natural kind of physical phenomenon, not a mystical thing. I mean, it's too complicated for me to get into at this point. But so there is this general theory. Okay, so from what's called the post-quantum theory, you can make an argument that this future horizon, besides being a computer, it has what's called signal non-locality, so it's actually a conscious computer. So it's cosmic consciousness. It's what it is. It's cosmic consciousness. I mean, it really is. So it's sort of exactly what, in theological terms, Teilhard de Chardin anticipated. I mean, it hasn't reached the Vatican yet because he's gone.
So, Jack, to simplify it then, with Flatland, you remember the Flatland by A Square,
Yeah.
Instead of the sphere coming through and the square being raised above and given some consciousness, the sphere is coming from the future.
Yes.
And we're actually...
Well, we're actually okay.
Growing,
Well, we are images. Okay, what do you learn the Bible? Man is in the image of God. Well, that's quite literally true. That God is the hologram on this omega. I call it the omega surface. It's a computer, in a technical sense. MIT physics. Mm-hmm. And it's not like crazy physics.
Right.
And this guy Gerard 't Hooft. It's a kind of ironic. Gerard 't Hooft, a Nobel Prize physicist, and he came up with the crazy hologram idea. The idea that we are holographic images is really Gerard 't Hooft's idea. He's a very stuffy Dutch professor at Delft, I think, in Amsterdam, and he's very against Brian Johnson. He's very anti-paranormal. All that stuff. He doesn't realize, but he didn't ask. He assumed. And also my friend Lenny Suskind, professor at Stanford, who I went to graduate school with. We were students together. They think it's the past particle horizon. They think the hologram is the past particle horizon. But the reason why it can't be that, because you get the wrong numbers. It's got to be the future horizon. And that's, it's debatable.
That makes sense.
Yeah.
Why do we age?
Okay. Oh, good. Thank you. Why do we age? Because, okay,
That's why she's here.
thank you. Very simple. And this, on the holographic thing, it becomes a trivial thing. And I should have had a diagram, which I didn't put in this picture. But what she does, what Tamara Davis does in her thesis, she computes the area of the future horizon. The area of the future as a function of cosmic time. So when it starts at the omega point, I'm sorry, the alpha point, so it's the alpha, I'm the alpha and the omega. The alpha point of creation to the omega point is the far future, where God is totally developed, so to speak. That's the maximum area, so to speak. That's the maximum channel capacity, okay, of God's mind, you see. It starts out at 1 bit, like a little embryo. It's just like one single cell. It's exactly, So it starts out at 1 bit. She can, and this is computed from Einstein's field equation. This is not just, she computes it, computer simulation, and it reaches what's called an asymptotic constant value. See, that's the dark. Turns out that the dark energy density that we measure from the supernovae, the reciprocal of that, 1 over the dark energy density, is proportional to the area of this thing. Let me get back. I should just send this picture. Okay. So here's like a picture of our future horizon, but from the outside. But just imagine we're inside at the center. Okay. So the question is the number of these. Each little triangle is what's called a pixel. It's a bit of information. It's like a quantum bit. It's like a quantum, actually a post-quantum computer. So it turns out we know exactly how many there are. There are 10 within a factor of 10, or maybe within a power or 2 of 10. There are about 10 to the 122 bits of information on this thing. That we measure that from the dark energy density measurements of the astronomers and using the theory. So about 10 to that's 122 power. That's 10 times 10, 122 times. Maybe 123, maybe 121, let's say 120, but it's around that. It's a big number. Okay. And that's the IQ, that's God's IQ, so to speak. So then it's final. But there may be other gods. See, we're not the only ones around. It turns out there's a multiverse. I mean, there's an infinity of these things. This is just what we are able to observe, limited by light signals. Now, if we had some kind of other telepathy sort of things and could remote view without light signals, then that's a whole other thing we don't get into. I mean that's really Twilight Zone stuff, And so that's kind of the picture that's developing here. Let me just kind of end it. Let me just go back.
Jack, can you tell us what is your definition of consciousness?
Well, let me finish this and then okay, fair enough. Oh, okay. Now look. Here's a weird thing. More synchronicities. This is the ceiling of the Sistine Chapel, right? And look what this is. There's God in the future, reaching back in time to Adam creating. This is like symbolic of the whole picture, right? This is a glorious idea I'm talking about, guys. I don't know if people like to. So, but look what that is. But strangely enough, and this is weird. Strangely enough, the personal physician of Pope Julius II was the Pope who commissioned this. Personal physician was Samuel Sarfatti. In Venice, and of which I've allegedly descended, probably, who knows, but and he was Michelangelo's anatomy teacher. And according to there's a Turner Classics special on Michelangelo and Raphael and Leonardo. There's this thing. There's this whole scene where it was, in fact, we have the family crest, the Sarfatti crest is from all this, because of also the Sarfattis did what's the technique de Tintoretto, that kind of that technique, terracotta, what's it, the Tintoretto, the painting technique. I forget what it's, no. So, well, it doesn't matter. But in any case, it was allegedly Samuel Sarfatti who brokered the deal, the business deal, for Michelangelo to paint the ceiling of the Sistine. Okay, and there we have, what I'm talking about, basically. I mean, it's like it's like the once in the future. God is this maximally conscious computer in the future, you know, that's computing us. We are in its image. We are literally its image. Literally like the holographic images. Yeah, and that's the whole there's whole mathematics in this. I'm speaking kind of metaphorically, but it's actually technical. It's as a poet might say it, you know, in a dream. I'm trying to translate some pretty advanced theoretical physics into popular language, so you have to understand where I'm coming from. All right, so then.
So how do we get around the arrow of time?
Okay, well, I just did, because what happens is the area at the alpha point is just one pixel. You know, it's quantum gravity, so it's one. It's not a continuum. Everything is finite. It's like a finite state machine, and then it grows to 10 to the 122 as the universe expands. Because remember, space itself is a holographic projection from this surface. There's like this computational program that's going on the surface of this expanding thing. As it expands from the anti-gravitational repulsion, as it expands, it's getting more complicated. As it gets more complicated, it's smarter and smarter, and it's learning and learning, and becomes the mind of God, and it reaches its maximum development in the far future, and it projects back to create itself in a self-consistent loop. That's kind of the picture. Okay. So it explains why we age as space expands.
So are we already old, really, and we're just seeing ourselves?
No, I don't know. Well, I don't know what that means, really. I mean, there's what's called the block. No, there's. I mean, well, you can think of it like we're strips of film or some, frames of the film. Mm-hmm. The film is there. I mean, I don't know. Really, I mean, that's a dangerous word, really. What's reality? You got to be careful. But there's a technical. I mean, you have to look at what are called space-time diagrams and special relativity theory, and it's called the block universe picture. And that's
so like the future is coming in, and we're kind of aging as we comprehend it.
Yeah. Well, yeah. Actually, it turns out there's going to be both. This will be both it's coming from actually both directions, because there are still efficient causes. There's still efficient causes, but the efficient causes are basically generated by the final cause. It kind of like loops back. It's kind of like a backwash, something like that. And there's actually, I'm not getting into too many technical details. Okay, so that's kind of the picture. Picture is that we are, and it's a crazy, as I said. Okay, there's physicists tend to have a sense of humor, and I mean, at the highest, the theoretical physicists do at least. And well, they used to. I don't know if they still do, but there was Niels Bohr and Wolfgang Pauli, the guys who created quantum mechanics in the 20s, and Werner Heisenberg and all these guys, and they were always arguing with each other. And Bohr once told Pauli, "Well, Pauli, I think your idea is crazy, but is it crazy enough to be true?" So there's that kind of thing. And this is a very crazy idea in the sense of it violates what people normally think. But of course, most of our discoveries in physics have been very anti-common sense, but they work. I mean, unfortunately, atomic bombs explode. Computers work, airplanes fly. And you have to always remember that the real the moju there, the magic is physics. Everything's based on on Einstein's field equations, Maxwell's electrodynamics. It actually works. It enables us to control the material world to some extent, though we're not doing such a good job now, I guess. But so that's the picture. Okay, so I think I could. Well, here, let me just quickly go through the pictures, because
and consciousness, don't forget.
Yeah, the consciousness. But this is your guys. This is your image, right?
Yeah.
So there you got it. The Star of David. There is the white triangle. Is the future horizon. That's the mind of God. The hologram. Okay. And the black one is the past particle horizon. So there's the omega point. Why? I don't know why it's 3 pi. Why is it 3 pi? I would actually make it 4 pi because of what's called spinor theory. But that's okay.
Point on the screen, Jack. Can you point on the screen?
Yeah. See, okay. Here's the alpha point of creation. Here's the omega point. It's actually infinite clock time, but it's a finite conformal time. And we're actually, we're inside that. We're caught between the two triangles, so to speak, the two horizons. Except I would, for aesthetic, technically the two things meet, kind of thing. The triangles are not quite positioned correctly in terms of the physics, but it's good enough. It's close enough. And then we have.
It was 125 years ago.
Yeah, right.
They were a little longer.
And here, here's basically Blake's picture says it all, right? There's God, and what is he holding? That's the future horizon. That's the hologram. And then project. Okay, there it is. That's the mind. There's God's alive and well on the future horizon. Is what I would say. Nietzsche said God was dead. Nietzsche was wrong. He was depressed anyway. He had syphilis.
So Jack, if we have intention, how does that impact the future horizon?
Well, does it? We have intention. That's a sticky wicket. She's asking about free will. Just wait. Well, let's skip the text. So that's the computer. That's just an image like we're inside the horizon. I forget where I got that from. There's also that great thing with a person's knocking through. That's Celtic, right? Yeah. That's Irish, right? Oh yeah, I was in Dublin. I saw all those Celtic things. Yeah, that's Ireland. And then we. And this is all. He was going to play, the magic flute, the Zara flute, and this is Zaraastro. It sounds like Sarfatti a little bit. And here's like an image. See, we're at the center, so to speak. Yeah, it's a very strange thing because I glossed over that. It turns out in these solutions, the future horizon is what's called observer dependent. So technically, everyone has their own. But I mean, it's so big and we're so close together, it's the same one. But technically speaking, it's like almost like the Leibniz monads, So we're all in this little bubble. Right? George Bush was in his bubble. Well, everybody's in a bubble. So that's kind of symbolic. But this is like a picture of the future horizon, figuratively. That's from a magic flute. I guess I forget who's. Okay. Now this. Here is a pie chart. There's the dark energy, 73%. That's the anti-gravitational field. That's accelerating the rate of expansion of the universe. There's the dark matter, like the galactic halo. That's pulling in. Now, the dark matter acts on small scales because it's attractive. Things clump. And since the dark energy is repulsive, it tends to spread out. So the dark energy dominates the large-scale structure of the universe. The dark matter dominates the small-scale structure, and it has to actually do with the way galaxies form and the way stars actually form.
But aren't they saying that now that the dark matter is much, much greater?
No, there it is. The dark energy is 73%, dark matter is 23%, and we are like, in that little atom stuff, he is like 4%. That's it. That's the way. Those are the facts, man. Just the facts.
That's the latest.
Yeah, this is the latest. This is the latest. Anything you read to the contrary, either you're misreading it or the guy doesn't know what he's talking about. But that's it. And then now this is the data from Berkeley. From this data, it's detailed. I mean, it's complicated. From this data, they found that the universe was accelerating. That's from supernovae data. And this is a computer simulation of pockets of dark matter. Actually, the red patches. This is from NASA, like Creon Levitt, does this kind of thing. The red patches show where the dark matter is. I mean, it's just a computer thing. And then this diagram here shows about 4 different experimental techniques of measuring various key parameters of this picture, and they all converge kind of here. They all converge here. So that's why we have confidence that different experimental methods are all getting the same numbers. So it's a kind of truth there, it's an objectivity. That's why we have confidence that this is actually not so crazy an idea. Okay, and then this is here's the alpha point. This is just a visualization how to visualize the creation of the universe. And look what he has at the end of the thinker, the Rodin's thinker. That's the mind of God. The cosmic consciousness. But the cosmic consciousness is projecting back, in, like final causation, teleology, projecting back. We are actually images of it. We are actually computations, so to speak. I mean, it's pretty hard to. This is computation. It seems pretty solid, But that's the idea. I mean, these are the ideas that are floating around. Physicists are crazy, but are they crazy enough to be true? So. Okay. Well, this is the original. I won't go. But this is the original Wheel of Feynman picture from 1940. It's in a paper by John Kramer, who's a physicist today, and he from his papers. But I won't go into all the details. But if anybody was interested, just Google John Kramer transactional interpretation of quantum theory, and I think that's. Let's see. I think that's. And the Freemason symbol again, past the rise of beauty. That's interesting. They have G. Either for God or gravity. Newton's constant is G. So there's a Freemason symbol. And so they all have these triangles, right? You have two triangles. So the triangle going down, that's the future, and triangle going up is the past. And that's